here today. So first thing, margin of error. We just want to kind of discuss this a little bit more. Margin of error was the distance we reach in each direction from our statistic. So again, when we think about what we're doing with confidence intervals, we're taking a sample and we're calculating either a sample mean or a sample proportion. And then with that particular snapshot, so that is a guess at what the true value is. So we're going to start at that particular point, that p hat or that x bar, and then we're going to reach so far in each direction. And what we're hoping is when we reach in each direction, we're going to create an interval of values that will capture the true value. So the true mean value of the population, or the true proportion of the population. So this margin of error describes the distance we reach in each direction. Okay? So we kind of talked about that formula yesterday. So the point estimate, that's your x bar or your p hat, your sample statistic. So that's the center of your interval, and then you're going to add and subtract your margin of error. That's going to tell you how far to reach above and how far to reach below from that particular point. Okay? Now, when we look at margin of error, when we change our margin of error, we change the confidence that we have in our interval to capture the true proportion or the true mean. Okay? So remember yesterday, when we looked at this graphic, we had a 95% confidence interval. So we were 95% confident we were going to capture the true value, but how far did we reach in each direction then? 2 standard deviations, right? We reached 2 above and 2 below. Now notice, we could create a more accurate track. We could create a more accurate interval in terms of making sure we have a better chance of capturing our true mean or our true proportion. So notice with this one, we now have 99.7% confidence. But in order to reach that confidence, what did we have to do to our interval? We had to reach out farther. Now we're reaching 3 standard deviations in each direction, right? So when you think about that, if I reach farther, I can be more confident that I'm going to catch the true value. But when I start to reach farther, what ends up happening as far as being able to pinpoint the true value? Yeah, we can't be quite as accurate. It gives us more area to work with to search for that true value, right? So when we look at this whole balancing act, in general, if we want to be more confident in our interval, we need to end up being less precise. We need to widen that interval. The exception to that, and I do want to make sure you guys write that down, increasing sample size. If we increase our sample size, we can actually narrow in on that true value without losing confidence. So by gathering a larger sample, we would be able to zero in on that true value without sacrificing confidence in our interval. Okay? So to kind of visualize that, if I created a 95% confidence interval, and let's say my sample was 40, so sample size of 40, I might have an interval that would be about this wide. Okay? Now, if I take that same information, so from the same population, I still want a 95% confidence interval, but I increase my sample size to, let's say, 100. Well, if I increase my sample size, what about my distribution changes? There's less variation, which means I don't have to reach as far to go 2 standard deviations above or below the mean, because my standard deviations are smaller, right? So if I do a 95% confidence with this bigger sample size, everything else remains the same, I can actually shrink my interval down. So now I still have 95% confidence in my overall interval, but notice I have a lot less area to work with in my interval, right? Same thing can happen if I want to increase my confidence. If I wanted to increase my confidence and I stay at n equals 40, so if I wanted to go to like 99% confidence, but n was equal to 40, I'm going to have a much wider interval than I started with. To be more confident, I have to widen it out. Unless I increase my sample size. If I increase my sample size, I can keep the same width, but increase the amount of confidence I have in the interval. So I'm not sacrificing that precise look for confidence. So the main thing I want you guys to realize here is if you increase sample size, you can generally shrink down the interval with which you're working on. Does that make sense? It also means that you can increase confidence without sacrificing the preciseness of your interval itself. So you don't have to make your interval wider to get the same confidence or more confidence. You just have to increase your sample size. Okay? If you don't do anything to sample size, so if you keep the sample size the same, to become more confident, you have to widen your interval. To become less confident, you can shrink your interval. So if we had an interval at 95%, but I don't care about being that accurate, I want to maybe only have 80% confidence, I can shrink my interval down quite a bit. Okay? So when you're setting up your confidence intervals, you always have to keep in mind this balance between certainty and precision. How certain are we that we capture the true value, but at the same time, how precise can we be in narrowing down that true value? Okay? So, as far as confidence intervals go, the most common percentages that are going to be used are generally 90%, 95%, and 99%. Okay? So these are the three that are probably the most commonly used. However, you can use whatever percentage you would like. You might see some intervals that are 80% or 85%. If for some reason you wanted to have like a 92% or a 96%, I mean, you can use whatever, but these are probably the three most common. And as we progress through these confidence interval problems, what you're going to notice is these show up enough that when we start putting in other values that we're working with, you're going to start memorizing some key values that go along with these particular intervals. Because they're going to show up so much, it's just better to know them without having to look them up every single time. Okay? So those are going to be kind of your key percentages to key in on. All right. One quick thing here, and this is going to be something we gloss over today. We get more in depth in next week. But we're going to start talking about this idea of critical values. Okay? So what we've talked about so far is when we create our interval, we use the point estimate plus or minus the margin of error. That margin of error as a whole tells us how far we reach in each direction. But that margin of error is comprised of two parts. There's two different aspects of the margin of error that have to get figured out here. So what we look at here, statistic, that's just another word for the point estimate. So this is your x bar or your p hat. Now margin of error consists of a critical value and the standard deviation of your sample statistic. So yesterday, we did talk about one of the intervals where they gave us the mean and standard deviation. We created the confidence interval. Okay? So they said that the mean was 240, the standard deviation was 5. We want to have a 95% confidence interval. Well, with 95% confidence, what we said was we have to reach 2 standard deviations in each direction, right? That 2 is what we consider the critical value for that confidence interval. Since we wanted 90 or 95%, we need to reach 2 times the standard deviation in each direction. Now, if we change our confidence level, so if we wanted to go with 90% instead of 95%, our critical value is going to change. The standard deviation doesn't change because of confidence level. So that's going to remain constant throughout. How far we want to reach changes based on the confidence level. And the reason is our critical value changes. So for a 90% confidence level, we would only reach 1.645 standard deviations above the mean and below the mean. And that 1.645 is a value we're going to discuss how to find next week. For now, what you need to make sure you understand is that the critical value, when we use that term critical value, that tells us how many standard deviations wide we want to make our interval. So how many standard deviations do we want to reach in each direction? And the value of our critical value depends entirely on the confidence level that we're working with. Okay. Okay with that? All right. So knowing what the critical value is right now is all I need you to know, not how to calculate it yet. We'll talk about that next week when we get into the actual proportions and means for critical or confidence intervals. So just a couple of cautions here. These aren't things you necessarily have to write down. These are just things to kind of keep in mind as you go through your creation and interpretation of confidence intervals. So first, the way we calculate a confidence interval depends on our sample coming from an SRS. It cannot be any other type of sample. So you need to make sure that your sample is an SRS, or you need to be able to justify the sample being representative of the entire population. Okay? So the key here, you need to make sure that you have an SRS before you can start calculating anything with your confidence interval. The margin of error. Now the point of the margin of error, we reach on either side. The reason we have to have a margin of error is because we know when we collect our sample, the value we obtain is most likely not the value we actually want. It's not going to be our true population proportion. It's not going to be our true population mean. So that margin of error gives us a plus or minus to work with. Here's the value we found from our sample, but if we reach this far in each direction, we should capture the true value that we're interested in. Okay? Now, that margin of error only covers chance variation due to random sampling. Every time we take a random sample, remember, we get new information. If I went out and collected one random sample, and then I have one of you go out and collect a random sample, and then another person go out and collect a random sample, we're all going to come back probably with different values, which means we're all going to come up with different intervals. So the intervals, that margin of error, accounts for that random sampling error. It does not account for biases that result from undercoverage, non-response, or response biases. So if you have any of those biases in your collection, you are going to run into issues probably, because the margin of error can't account for those types of bias. Okay, so always be aware of that. That's it.